All right, this will be our last presentation in this block, and then we'll take a second to grab some questions. So Susanne Wiesner is an assistant professor of plant and earth science and Hub-funded faculty member at UW River Falls. She's joined today by her student Jade Wodack to introduce their project about creating a greenhouse gas budget for the Mann Valley Farm. So thanks to the speakers.
Yeah, thank you for having us here. So I don't have to go through this title. This is a project that was funded through the Dairy Innovation Hub that also funded Jade this past summer. I want to start with acknowledging my funding sources. I'm really grateful for the Dairy Innovation Hub. Some of you might know I used to be a postdoc at UW-Madison, so I'm really grateful to be continuing this research. And of course, that the Dairy Innovation Hub is funding awesome students like Jade from UW-Madison. And then you can see there's a couple of other funding sources because the research that the Dairy Innovation Hub funds also leads to other funding as well. And then the collaborators, Paul Stoy, Michelle Watteau, as well as Lakshmi Prasad at UW-Madison. And then our new farm manager, Dwayne Thompson at Mann Valley Farm. I'm super grateful for his support during the summer. And I always like to include our dairy cows as well, the ladies. And down below that picture is actually that's our beef herd at the Mann Valley Farm, and I included that because that was a funny coincidence when Jade and I were working there this summer. We turned around for literally 10 seconds, and they were all walking around, and suddenly they were staring at us like this, and I always wish this would be my students in my classes, which, you know, how it goes. This is why we're here. Animal products, which includes dairy, has and is projected to have the highest ecological or environmental footprint. So in the top there, you can see the greenhouse gas emissions are already the highest of all other agricultural products, but they're also projected to increase. And then you can see animal products also contribute to water quality issues, right? We're all aware of that. What I want to remind you of, though, is not that long ago, we had millions of bison walking around the Americas, right? And guess what they were emitting? A bunch of greenhouse gases as well. So it's not just about reducing greenhouse gases, it's about mitigating these greenhouse gases with a healthy soil and healthy vegetation. And this is our project. It's looking at improving the environmental and economic sustainability. You can see there's three parts to it. Basically, the first step that we started this summer is quantifying a greenhouse gas budget for the Mann Valley Farm. So basically, a baseline budget from which we then can maybe come up with improvements, as well as a climate resilience target, not just for Mann Valley Farm, but also using that for other farms as well. And then to me, small dairy farms are close to my heart. I really want to improve the economic stability so that we don't continue to lose them every year. On the right side here, these are all the measurements we're taking, and you can see they're all across temporal and spatial scales. So we take annual measurements of soil and forage quality, as well as with an eddy covariance tower, we can take really high-frequency measurements of CO2 exchange, so these are the greenhouse gases. Using drone and satellite techniques, we can actually upscale that so that we're not just looking at Mann Valley Farm, but we can use that information for other farms as well. And then in the center there, this is what we're focusing on today a little bit. This measures soil respiration. So soil respiration, keep in mind, is made up of microbial and plant respiration, so the CO2 that is coming out of the soil. And then I'll take it.
All right, so I'm going to talk a little bit about just our research in general. So this on your left here is a Mann Valley Farm. So it has around 425 acres. There's around 100 head of cows. Pretty big place. So that star there, that's circled by blue, is the eddy covariance tower. So as Susie said, it's kind of like a mini weather tower. It gives us high frequency readings of all the different things that we want to take data on. These little red dots, they may be a bit hard to see, but on the northern most edge of the map, there's a bunch of red dots, and then on the right-hand side of the map, there's a bunch more dots. Those are all where we put our soil colors, and that's where we find our soil data. And then that red little rectangle on that map is the dairy barns. That's where the cows typically stay. That's where we take some of our measurements from the cows. So one thing to remember is that cows emit methane, and what we're trying to do is we're trying to figure out what we can do to help balance and improve sustainability of the farm. So here we have our soil and vegetation. So soil respiration is a multifaceted component. So there's microbial so there's microbial and plants, right? So soil respiration is very important. And one thing to note is that healthy soil respirates a lot. So as you can see from our preliminary data here, alfalfa has significantly greater CO2 respiration compared to corn and pasture. And another thing to note is that our corn and alfalfa pastures were both irrigated. So there's not really a difference there. And as you can see, we have this giant jump in CO2 respiration between our 2 of our cornfields and 2 of our pastures. And so soils with greater slopes have less CO2 respiration. There's reasons for that. And if you have questions about the soil types at the top of this, you can come see me after and I'll be happy to answer those. So we use the drone to take a lot of our data. And so one of the things that we measured at some of the other farms that we go to is NDRE, or the Normalized Difference Red Edge Index. So that measures the greenness of the plant or the health of the plant. And so the y-axis on these graphs is the greenness of the plants, and then our x-axis is the nitrogen application rate. This is in pounds, I believe, per acre. And so what you can see here from this graph is the more nitrogen application we put on, generally the higher the greenness. But you can also see that plants at lower elevation are greener. So that leads me into another thing that our drone was awesome enough to get for us, which was the difference in elevation. And so what we did was we took basically the lowest elevation and the highest elevation. We found the difference. It gives us about 6 meters of difference. And so what we were finding is that our difference in elevation can also give a difference in height. So what we're finding is that the lower the elevation, the taller the corn plants. And I'm talking like 10 feet tall. Those things were huge going through those fields. And what we're finding is that generally there's less greenness of the plants on the slopes, which means there's less nitrogen in the plants, and they're also a lot shorter than everywhere else. So this kind of raises the question of if the plant isn't as healthy on the slopes and it's not growing as tall, it's not producing as much, should we be farming or, I suppose, growing crops on those hills?
All right, so going back to agricultural sustainability, which is what this project is about, right? So in this graph here, and I apologize, the citation will pop up in a second. I'm not as great with animations, apparently. But this one is looking at agricultural sustainability in terms of thermodynamics. And I like to remind my students, and I like to remind you, we are on a rotating planet in a near vacuum circling around the sun. That means we are subject to the laws of thermodynamics. And I would like you to keep that in mind, because as this study, which was published in, I can't remember, I think 2015 now, can show you is, in terms of thermodynamics, growing crops at maximum yield might not be the best thing to do. So as you can see in this graph here, maximum efficiency is actually associated with a lower environmental footprint. So if we can shift our systems to something that can implement this philosophy, we can reach sustainability. And if you recall what it means to be a sustainable farm, this is from the USDA NIFA program. I'm not going to go through all of these right now, but I want to, if you read these different bullet points, really keep in mind or ask yourself that question of how many farms do you know that meet all of these points. Agricultural sustainability is not just a couple of them, it's all of them. So to me, it means a thermodynamic equilibrium. So not maximum yield, maximum efficiency, so that we can take care of our soils as well as yield. And then in this lower graph here, This is actually from a project that was funded by the Dairy Innovation Hub for my postdoc as well, from the U.S. Dairy Forage Research Center farm, that indicated that just a small proportion of the farm, 1/3 in this case, can mitigate over 50% of the greenhouse gases emitted at that farm. So that's pretty great, right? It's just a small amount that we have to change. And something that I would like to finish with is we're talking about the environment and improving the resilience and all that. But keep in mind that we also, in addition to diversifying our agroecosystems, we also have to think about our economies and industries, because we are seeing more monopolies or monopolizing. And if you think about just seed diversity, genetic diversity, all these things, they play a role and the industry plays a role. So we need to diversify our economies as well. And then lastly, thank you for having me, but I also, if you see that little QR code there, this is a grant that was funded, again, because of the Dairy Innovation Hub by the USDA NLGCA, and it's actually a collaboration between UW Platteville and UW River Falls. So if you are a dairy farmer or know of any dairy farmers, come see me, because this is a grant where we basically want to build these collaborations better. So thank you.